Good morning students. This channel covers syllabus of CBSE maths of classes 9 and 10. I am doing sums from all the exercises, important sums and the sums of all the models I am doing. Other than the sums, other than the exercise sums, I'm going to do extra sums also. So whatever sums I am doing, in each model I am doing one sum. Okay, so if you practice these sums, I make sure that you will be getting very good marks in your examinations. But in each model, one sum only I can able to do. Other than this, daily practice is very much important, especially for my maths subject. If you start practicing daily, you will be getting very good marks in the subject. So please subscribe. Thank you. Today we will see class 10 coordinate geometry sums. We are doing exercise 7.1 extra sums. Today we are going to do exercise 7.1 extra sums. Already I have completed 7.1 exercise, important sums and sums in all the models I have covered in my previous videos. Okay, so this one. An equilateral triangle. First sum is an equilateral triangle has one vertex at 0, 0 and another vertex at 3, root 3. Find the coordinates of the third vertex. So this one we will be using only distance formula. So as equilateral triangle, all the length of all the sides will be equal. So AB is equal to BC is equal to AC. AB is equal to BC is equal to C. All the sides are equal. So this statement definitely you need to write. And I am taking x values. Third vertex only are asked to find. So that I am taking it as A, x, y. And B is 0, 0 and C is 3, root 3. These two vertices are already given in the question. This one we are asked to find. So that I will take it as x, y. So this and all you have to write definitely. Given AB is equal to BC is equal to CA. Reason you have to write equilateral triangle. You have to write. Then let A and all you are only taking A, B, C. So that also you have to write. A, x, y. B, 0, 0. And C, 3, root 3. These are the things given. Now we will use distance formula. AB is equal to root of x2 minus x1. So 0 minus x the whole square plus 0 minus y the whole square. So this one when we simplify, you will get minus x the whole square. So this will be x square plus minus y the whole square will be y square. So this is the length of AB. AB is equal to root of x squared plus y squared. Then next one is BC. BC is equal to root of B and C. B will be root of 3 minus 0 the whole square plus root 3 minus 0 the whole square. So when you simplify this, 3 minus 0 is 3. 3 squared is 9. Plus root 3 the whole squared is 3. So 9 plus 3 it is root 12. This is the length of BC. Okay. Then next one is CA. CA is equal to root of C and A. C is 3 minus x the whole square plus root 3 minus y the whole square. Okay, we will keep this as it is. Now, AB is equal to BC is equal to CA. Somehow, we have to simplify these things. All these things are equal. That is one thing given. So, somehow we have to simplify all these things and find out the value of the coordinates of x and y. That is our ultimate aim. So, we will be comparing two length and we will be finding the value for x and y. Okay, first I will compare x squared plus y squared, that is AB and BC. First step I am going to compare AB and BC. Okay, then next one is I will compare BC and CA. Step by step I will tell you. First one is AB. I got it as, first I am taking two sides. AB is equal to BC. Okay, so AB I got it as root of x squared plus y squared. And BC I got it as root 12. So when I am squaring this, I will get x squared plus y squared is equal to 12. So this is my first equation. My aim is to get the value for x and y. Okay. Now I will take, this is the first one. AB is equal to AC. Now I am taking CA is equal to BC. So what is the length of CA? Root of 3 minus x the whole square plus root 3 minus y the whole square is equal to root 3 minus y the whole square is equal to root 12. I am taking this one, root 12 I am taking. So as usual, when I square this, I will get 3 minus x the whole square plus root 3 minus y the whole square is equal to 12. I am getting this. Okay. Now as usual, a minus b the whole squared formula I am expanding. So this will be 9 minus 6x plus x squared plus root 3 the whole squared is 3 minus 2 root 3y plus y squared is equal to 12. Okay. Now after this, x squared plus y squared, I am rewriting this, that's all. Minus 6x minus 2 root 3y plus 12 is equal to 12. Okay, here I have plus 12 and plus 12 is equal to 12. Okay, this 12 and 12, when I bringing this 12 to the other side, that will get cancelled. So this one I will get 0. So x squared plus y squared minus 6x minus 2 root 3y is equal to 0. Okay, now here I got the value for x squared plus y squared as 12. Okay, so here x squared plus y squared value is 12. So here I am substituting that value. So when I substitute that, I get 12 minus 6x minus 2 root 3y is equal to 0. So I will bring this 12 to the other side. So minus 6x minus 2 root 3y is equal to minus 12. Okay, so I get this as 6x plus 2 root 3y is equal to 12. Okay, now I will take 6x is equal to 6x plus 2 root 3y is equal to 12. Okay, 2 root 3y is equal to 12 minus 6x. I am keeping this y value as it is and bringing the 6x to the other side. So, y is equal to 12 minus 6x by 2 root 3. Okay, so if I am taking like this, 2 root 3 is in the denominator. If you want, you can keep this x as it is, this side. You can bring this y to the other side and bring the 6 also. That also you can do. Anyway, it can be done. So, y is equal to 12 minus 6x by 2 root 3. So, this is my y value. Okay. So, this y value, whatever y value I got, I will substitute it in this equation. In any equation, you can substitute. Either in this equation also, either in CA, you can substitute, or in AB, you can substitute. If we substitute, what we will get? We will get the value for x. Okay, we will substitute it. After this, y value. So, I am taking this x squared plus y squared is equal to 12. Okay, so x squared plus y squared is 12 minus 6x by 2 root 3 the whole square is equal to 12. Okay, so now after this, I have to expand. So x squared plus this one, when I simplify, 12 minus 6x the whole square by 2 root 3 the whole square will be, this is 4, 2 2s are 4, 4 3s are 12 is equal to 12. Okay, step by step calculation has to be done very carefully. So this one will be 12 LCM 12x square plus 12 minus 6x the whole square is equal to 144. So when I take 12 as LCM here, I'll get 12x square plus the whole term will be here. Denominator will be 12. When I multiply this, I'll get 144. Okay, so then 12x squared, I'm expanding this plus this is a minus b the whole squared. So a squared minus 2ab. So 6 2s are 12, 12 12s are 144. 144 ab, that is 2 into 12 into minus 6 will be minus 144x plus 6 6 are 36. X squared is equal to 144. Okay, so here also plus 144, here also plus 144, that will get cancelled. So 12 plus 36 is 48. 48x squared minus 144x is equal to 0. Okay, so when I take 48x outside, balance will be x minus 3. So 48 3s are 144. Okay, is equal to 0. So now, since this is a quadratic equation, we will be getting two values for x. That is 48 x is equal to 0. So you will get x value as 0 and x minus 3 is equal to 0. So x value will be 3. So now I got two values for x. Okay. So here x is equal to 0 and x is equal to 3. So these two x values I have to substitute here in this y value and two y values I will get. That how I'll be getting, I will show you. Listen. So this one is, first I will take x is equal to 0. So if I take x is equal to 0, what will be my y? Y is equal to 12 minus 6 into 0. Here only I have x into 0 by 2 root 3. So 12 minus 0. So 12 minus 0 is 12. So this will be 12 by 2 root 3. The denominator we are having 3. So if I rationalize this one will be 6 by root 3. If I rationalize this, I will get 6 root 3 by 3 I will get into root 3 by root 3. This is how we have to do rationalization. This one also I have explained you in one video in rationalization. So this is 6 root 3 by root 3 into root 3 is 3. So I will get 2 root 3. So if my x value is 0, my y value is 2 root 3. Okay, then if my x value is 3, my y value will be 12 minus 6 3s are 18 by 2 root 3. So again the same way it has to be simplified. Here it is 12 minus 18 is minus 6 by 2 root 3. So if it is minus 6 by 2 root 3, same way, this is 6 by root 3, 2 root 3, no, same rationalization. Okay, 2 3s are, so this is minus 3 by root 3 into root 3 by root 3. So this will be minus 3 root 3 by 3. So I will get minus root 3. So if I get, this is my y value. So if I get x is equal to 3, my y value is root 3. So what are the two possible vertices I can get for A? One is 0, 2 root 3 and the other, this one will be the A values. 0, 2 root 3. When I substitute 0, I will get 2 root 3 and when I substitute 3, I will get minus root 3. So this is the answer for that question. So this will be my, these are the two possible vertex I will get when I simplify in that way. The sum may be very big, but you practice step by step, you do practice. So whatever they are asking, you can able to do. Second sum. The vertices of the triangle ABC are A 0, B, B 0, 0 and C A, 0. If the length of perpendicular from B on AC is P, then prove that 1 by P squared is equal to 1 by A squared plus 1 by B squared. So whatever is given, first we will draw the diagram for the given thing. The vertices of the triangle ABC are. So triangle is given. For that, vertices is given A 0 comma B, B 0 comma 0. So B 0 comma 0 and C A comma 0. So since this is 0 comma 0, you can take this in a coordinate plane. Okay, so the length of this BC will be A units, and the length of this AB will be B units. That is AB is equal to B and BC is equal to E. Okay, then if the length of perpendicular from B on AC, on this is AC line, so a perpendicular is drawn from B to AC is P. So this length is given as P. It is given in the question. Okay, then prove that 1 by P squared is equal to 1 by A squared plus 1 by B squared. Okay, so now since it is given as a right angle triangle, we can take this as two types of triangle, that is ABC with base BC and height AB. Okay, this is one part. The same triangle, we can take it in another way, that AC as the base and this length as, if you take this as D, BD as the height. Okay, so in two ways we are going to take this triangle. One with the base BC and height AB. Already it is given as a right angle triangle only. So with base BC and AB, triangle ABC we are going to take. The same triangle ABC we are going to take with base as AC and height as BD. So we'll use half BH formula, area of triangle. So area of triangle ABC in two ways. Okay, so one way with base as BC and height as AB. If you take like this, okay, we'll get half into base is BC and height is AB. So this will be half into BC is A and AB is B. So half AB. This is one thing. The same area of triangle ABC with base as AC and height as AD and height as AD. Sorry, BD and height is BD. Then you will get half into AC into BD. So half into AC length. How can we find the length of AC? So we'll be using distance formula. To find the two coordinate points are given. So we'll be finding the distance using distance formula. So here itself we'll do. So AC is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. So when you simplify this, so this is the distance formula. This is the length of AC into BD length, already it is given as P. Okay, so this one when you simplify, half into root of A minus 0 the whole squared is A squared plus 0 minus B the whole squared is B squared into P. So now all the area, in whatever way you are taking, the area will be same only. So these two areas will be same. So that is, we can equate these two things, half AB into half root of A squared plus B squared into P. Half AB is equal to half root of A squared plus B squared into P. Both the areas are equal. In however way we are taking, area will be same. So half will get cancelled. We are asked to prove this one. 1 by P squared is equal to 1 by A squared plus 1 by B squared. So I am squaring these two sides. So I get A squared B squared is equal to, when I square, I will get only A squared plus B squared into P squared. Okay, so when I simplify this, I have to get this one. So A squared B squared, I bring this P squared down. P squared is equal to A squared plus B squared. Okay, but I have to prove this only. So, I will bring this a squared b squared to the denominator, opposite side. So, 1 by p squared is equal to a squared plus b squared by a squared b squared. That's all. So, 1 by p squared is equal to this a squared b squared is common to both the numerators. A squared by a squared b squared plus b squared by a squared b squared. A squared will get cancelled. B squared will get cancelled. So 1 by p squared is equal to 1 by b squared plus 1 by a squared. This is the thing I wanted to prove. So I have proved this. Find the center of the circle passing through the points 5, 7, 6, 6 and 2, 2. Find its radius. So when you are drawing a circle, it is given that find the center of the circle. So you will be finding the center of the circle that is not given. Okay. Passing through the points 5, 7. So one point is 5, 7. Take this as B. Okay. Another one is 6, 6. 6, 6. Then another one is, another point is 2, minus 2. Okay. So now this AB, AC and AD are the radius of the circle. So all the radius are equal. So AB is equal to AC is equal to AD. All these three radius are equal. So by equating these radius given, we'll be finding the points of the center. That is x, y coordinate we will find. Okay. So AB is equal to, length of AB is root of x minus 5 the whole square plus y minus 7 the whole square. This one has to be simplified. Okay. Then AC is equal to A and C. AC will be x minus 6 the whole square plus y minus 6 the whole square. This is AC. Then BC. Sorry. AD is equal to root of x minus 2 the whole square plus x plus 2 the whole square. So minus of minus, x plus 2 the whole square. Now what is given? AB, AC and AD are equal. That is the radius. So it will be equal. Now we'll be equating two things together. AB is equal to AC. AB and AC we will equate and AB and AD will equate. Any two things, that is when you are taking any two things in common, one should be common to both. Okay. AB and AC, if you are taking, then AB and AD or AC and AD. Okay, anything should be like that you have to take. So AB is equal to AC. So first I am taking AB is equal to AC. Then next one is AB is equal to AD. AB is equal to AD. So when I take this, root of x minus 5 the whole square plus y minus 7 the whole square is equal to AC is root of x minus 6 the whole square plus y minus 6 the whole square. Okay. So now squaring on both sides, this root will get removed. Balance will be these numbers, x minus 5 the whole square. Okay, I am expanding this. So x squared minus 10x plus 25 plus y squared minus 14y plus 49. Okay, I will write it the other side. AB is equal to AC. AB is equal to AC. So AB is, when I find the square, same thing only, I don't have space there, so I am writing it here like this. Plus y minus 7 the whole square is equal to AC is x minus 6 the whole square plus y minus 6 the whole square. So squaring I will get only the numbers that are there inside. So when I simplify this, when I expand it to a minus b the whole square, a squared x squared minus 10x plus 25 plus y squared minus 14y plus 49 is equal to, this one is x squared minus 12x plus 36 plus y squared minus 12y plus 36. Okay, so these things has to be simplified now. So x squared and x squared, y squared and y squared. Now you have to bring x terms and y terms together. You will get an equation. X term and y term together I will take. So that will be minus 10x and minus 12x. So minus 10x. This minus 12x when I am bringing here, it will become plus 12x. Then here y I am having minus 14y. So this side 12 minus 12. So plus 12y I will bring. So this one is 25 plus 49. So that is 74. Plus 25 plus 49. It is 74 plus 74. Then on the other side 36 plus 36 is 72. So what 72? Here plus 72 is there. When I bringing it to the other side, it will be minus 72. So when I simplify this, 2x minus 2y plus 2 is equal to 0. So I got an equation with x and y variables. So again this can be simplified and I can write this as, when I divide it by 2, I will get this as x minus y, 2 on the other side. So it will be is equal to minus 2 for our convenience only. So x minus y is equal to minus 1. So this is my first equation. Okay, now as I told you, first I have taken AB is equal to AC. Now I will take AB is equal to AD. AB is equal to AD. When I simplify this, in the same way, I will get an equation with x and y variable. That has to be simplified and you will get the value for x and y. So AB value is x minus 5 the whole square plus y minus 7 the whole square. So I am taking the square and removing the root there itself is equal to AD is x minus 2 the whole square plus x plus 2 the whole square. So this has to be simplified. So x square minus 10x plus 25 plus y square minus 14y plus 49 is equal to x square minus 4x plus 4 plus x squared, sorry here it is y. So y squared plus 4x, 2 2's are 4x plus 4y. Okay, so x squared, y squared, x squared, y squared. So balance will be minus 10x plus 4x and then y is minus 14y and minus 4y. Now itself I am bringing the constant to the other side. So 4 plus 4, 8 here. Here I have 49 plus 25 is 74. So minus 74. Okay, so minus 10x plus 4x will be minus 6x minus 18y is equal to 74 and 8 minus 74 will be minus 66. Minus 66. Minus 74 I will get. Then on the whole I am dividing it by 6. Minus 6. So I will get x plus 3y is equal to, I am dividing it by minus. So I get 11. So this is my second equation. So I have to solve this first equation and this second equation to get the value for x and y. So first equation is x minus y is equal to minus 1. Second equation is x plus 3y is equal to 11. So simplifying, solving this, when I subtract this, plus x minus x will get cancelled. This one will be minus 4y is equal to minus 12. So y is equal to 3. So substitute this y value in any one of the equation. The first equation, x minus y is equal to minus 1. So x minus 3 is equal to minus 1. So x is equal to minus 1 plus 3. X value is 2. So I will get x value as, x and y value as 2, 3. After this, I have to find the value for the radius also. After substituting these values in any one of the equation, that is first center point I have kept it as A. Okay, then B, C, D are the other 2 points. So AB, AC, AD in any one of the distance formula, when you substitute this value for this 2 and 3, you will be getting the value for the radius. Okay. Is a radius. So that is 2, minus 2. So root of x minus 2 the whole square plus y minus of minus plus 2 the whole square. So x2 minus x1 the whole square plus y2 minus y1 the whole square. Now we got the x value as 2 and y value as 3. Okay, so we'll substitute this x value as 2. So 2 minus 2 the whole square plus 3 plus 2 the whole square. So this is 0 and this one is 5 squared. 5 squared is 25. So the length of AD, that is length of one radius, is 5 units. So that will be the length of AB is equal to AC is equal to AD is equal to 5 units. So this is the length of radius. Fourth sum. Find the value of y if A 0, 3, B minus 2, y and C minus 1, 4 are the vertices of right angled triangle ABC right angled at A. In this, hypotenuse on the other 2 legs are not given. So it is given that it is right angled at A. So when you draw a right angle triangle, the right angle is at A. So the other 2 sides will be B and C. So now from this you can note the vertices. So A is 0, 3 and B is minus 2, y and C is minus 1, 4. So here in this you are asked to find the value of y here for this vertex. Okay, so here since it is a right angle triangle, hypotenuse squared is equal to sum of the squares of the other 2 sides, that is BC squared is equal to AB squared plus AC squared. Okay. So since it is all these explanations you have to write. Since it is right angled, and you have to draw the diagram. Then you write BC squared is equal to AB squared plus AC squared. Okay. So BC squared. So using distance formula, we will find the length of BC. So BC squared is equal to. So BC squared means we don't want this root. BC is equal to root of you will get. So here BC squared itself. Since it is a Pythagoras theorem, since it is a right angle theorem, we have to use Pythagoras theorem to find the length of the sides. Okay. We have to prove this statement of Pythagoras theorem. So BC squared is equal to AB squared plus AC squared. So for BC squared, it is minus 1 plus 2 the whole square. Okay. So x1, y1, x2, y2. So x2 minus x1. So minus of minus plus 2 plus y2 minus y1 the whole square. Okay. Is equal to AB square. So 0 minus of minus 0 plus 2 the whole square plus 3 minus y the whole square. Okay. x2 minus x1 the whole square plus y2 minus y1 the whole square plus AC squared. So this one will be 0 plus 1 the whole square plus 3 minus 4 the whole square. So this one has to be simplified. So minus 1 plus 2 is 1. So this is 1 square. Plus this one is a minus b the whole square. So 4 4s are 16 minus 4 2s are 8y plus y square is equal to, this one is 2 squared is 4 plus 3 3s are 9 minus 3 2s are 6y plus y squared plus 1 squared is 1. 3 minus 1 the whole 3 minus 1 is minus 1 the whole square is again 1. Okay. Now we simplify this. So this y squared and y squared will get cancelled. And then 16 minus 8y. 16 plus 1 17. So 17 minus 8y is equal to 9 plus 4, 4 plus 9, 13, 14, 15. So here this side it is 15 minus 6y. So minus 8y plus 6y is equal to 15 minus 17. So this is minus 2y is equal to minus 2. So my y value is 1. So this is the y point for the b coordinate. Okay. In this video, I have completed exercise 7.1 extra sums I have completed. In the next video, I will be doing sums on exercise 7.2. Thank you.